Inside a truck on the streets of Geneva, physicists just drove the stuff that annihilates everything. 92 particles of pure antimatter, traveling at 47 kilometers per hour through the afternoon traffic. No explosion, no flash. The truck simply arrived. On March 24, 2026, the base experiment at CERN achieved something that seemed impossible. They moved antimatter. Not across a lab bench, not from one building to the next. 8 kilometers across their campus in a vehicle suspended in a magnetic cage. For 50 years, physicists have trapped antiprotons inside particle accelerators. But this was different. This was the first time anyone had ever taken that trap on the road. Antimatter is not theoretical. It is not metaphor. When an antiproton meets a proton, matter's mirror image, both particles vanish instantly. In their place, pure energy, released in light and heat. A single gram of antimatter colliding with a gram of matter releases the energy of a nuclear bomb, and physicists had just put 92 antiprotons inside a truck. The trap that held them weighed 1,000 kilograms. It looked like a metal cylinder, ordinary on the outside. But inside, superconducting magnets cooled to 8.2 Kelvin, colder than outer space, colder than the surface of Pluto, created a magnetic bottle. The temperature was minus 264.95 degrees Celsius. At that extreme, the magnets lose all electrical resistance. They become perfect, infinitely strong, infinitely precise. Electric fields pushed from the sides. Magnetic fields pushed from the ends. The antiprotons floated in that invisible cage, suspended in vacuum, unable to touch the walls, unable to meet matter. The whole system ran on liquid helium, the coldest substance humans have learned to work with, piped through the trap in constant circulation. Why go to such extremes? Because antiprotons are fragile. Any vibration can shake them from the trap. Any electromagnetic noise can disturb them. Physicists measure particles by how they behave in magnetic fields. The antiproton has a magnetic moment, a way it interacts with magnetism, a subtle signature. That signature is what BASE wants to study with unprecedented precision. For decades, this technology existed as a permanent fixture, bolted to the floor, wired to the building's power. Scientists went to the trap. The trap did not go to scientists, but the BASE collaboration wanted something different. They wanted to know the antiproton's magnetic moment with accuracy that has never been achieved. And they could not get that measurement at CERN. The Large Hadron Collider shares CERN's campus. It accelerates protons to 99.9999% the speed of light. When they collide, they create showers of particles. They create magnetic chaos. Fields pulse from the machine in all directions. They shake through the ground. They distort the measurements. The antiprotons inside the trap are so sensitive that even these distant vibrations corrupt the data. It is like trying to hear a whisper in a thunderstorm. BASE needed silence. They needed a location 700 kilometers away. They chose Heinrich Heine University in Düsseldorf, Germany, a university lab far from any accelerator, far from the electromagnetic noise. There, in a shielded room, they could measure the antiproton's magnetic moment 10 times more accurately than before. So on March 24th, they made a decision that seemed reckless. They loaded the trap into a truck. They drove it across CERN's campus, 8 kilometers, 30 minutes at highway speed, to test whether the system could survive motion. The magnets held, the vacuum held. The field stayed stable. The antiprotons arrived. The test worked. What is actually important in physics is often invisible. We see atoms and molecules and light, but we do not see the thing that determines whether we exist at all. In the first microseconds after the Big Bang, equal amounts of matter and antimatter formed. They should have annihilated each other. The universe should be empty, nothing but light. But something broke that symmetry, something tipped the scales. Matter won. Antimatter lost. We exist. Your planet exists. You exist. And physicists do not know why. This is not a minor question. This is not footnote physics. This is the question of existence itself. The antiproton's magnetic moment might hold a clue. Subtle differences between matter and antimatter. Differences so infinitesimal they require extreme precision to detect. Could explain everything. The proton and antiproton should be mirror images. But what if they are not quite identical? What if the antiproton spin, its magnetic signature, is off by 1 part in a trillion? That tiny difference might unlock the asymmetry problem, but the measurements require precision beyond what CERN allows. Vibrations from the accelerator, electromagnetic noise, all of it corrupts the signal. At Düsseldorf, without that magnetic storm, they can reach precision 10 times greater than before. They can approach that 1 part in a trillion sensitivity, and they have to move antimatter to do it. The March 24th test was a proof of concept, but it worked. 92 antiprotons survived the journey. The trap stayed cold, the field stayed stable. The helium did not boil away. The cargo arrived intact. Now base is planning the real trip, 8 to 12 hours on the road. The truck heading north out of Geneva, through France, into Germany. The trap bouncing over highway surfaces, vibrating, jostling. The magnets humming constantly, the liquid helium sloshing in its reservoirs. 92 particles that should not exist, that annihilate on contact with ordinary matter, traveling in a cryogenic coffin at highway speed through ordinary towns, past ordinary people who have no idea what is driving past them. No insurance company has ever covered this. No protocol exists for shipping antimatter across international borders, but base is moving forward. In the coming months, they will load the trap again. They will drive it 700 kilometers. They will deliver antimatter across an international border for the first time in human history. The implications radiate outward. If base can transport antimatter reliably, new possibilities open. Other experiments could use portable traps. Other universities could host antiproton research. Antimatter is no longer confined to the world's largest accelerator. It is becoming mobile. It is becoming distributed. But the deeper goal is clearer, solving the asymmetry problem. Every measurement of the antiproton edges physicists closer to understanding the universe's fundamental bias toward matter. Every test, every truck trip, every hour in a cryogenic transport brings them nearer to knowing why anything exists at all, why matter won, why antimatter lost, why we are here. What started as a question, can antimatter survive a journey, has become a quest for the universe's deepest secret. On March 24, 2026, base took the first step. They loaded 92 antiprotons into a truck. They drove them 8 kilometers across a campus. They proved that the impossible is possible. The universe's deadliest cargo is now mobile. It is searching for answers, and the search is just beginning.